Okay, boys and girls, here is your fraction ratio rates review. Let's just talk about fractions. Fractions, of course, here's a fraction 3 over 4 or 3/4. The top is called the numerator. And the bottom is called the denominator. Sorry for my messy writing. The numerator and the denominator. The denominator is on the bottom, D for down. And it is how many pieces the whole is cut up into. And the numerator is how many of those pieces we're talking about. So if this was a pizza, of course, the bottom means that you have 4 pieces, and you're talking about getting 3 of them. There's a different way to represent fractions. If I said, show me 3/5 of this wheel, you would cover in 3 of the 5 equal pieces. If I said, show me 1/4 of this rectangle, I would divide it evenly into 4 pieces and then color in 1. And if I said, show me 2/3 of this triangle, that's a little more difficult. Maybe if I cut it like this and like this, I'll get 3 equal pieces, and then I can color in 2/3 of that. Let's go on to putting fractions in order. If you've got the same denominator, this time they're all these fractions have to do with 11th. So whatever the whole is, it's cut up into 11 pieces. Here's 2 of the 11, 3 of the 11, 7 of the 11, and 9 of the 11 pieces. So 2 over 11 and 3 over 11. This one is obviously greater. And then this is greater, and this is greater. If the fractions have the same denominator, then you just compare the numerator, and you just figure out which is more. Obviously, 9 pieces is more than 7 pieces. Because they have the same denominator, then you just have to look at the top for that one. Now let's look at, what if you have the same numerator? What if you have the same number on top, but the bottoms are all different? Well, this is one where you have to kind of analyze the bottom this time. In the bottom, if you have a low number on the bottom, the lower number on the bottom actually gives you more in the end, because the pie or whatever you're dividing is actually broken up into fewer pieces. Let's say in this one, the pizza was broken up into 12 pieces, and you're getting 3 piddly little pieces. Whereas over here, the pizza's broken up into 5 pieces, and you're getting 3. You're getting more than half. And of course, 3 over the 3 equals 1. So the rule is, if you've got the same numerator, then you look at the denominator, and the lower number is actually greater. Now let's talk about improper versus mixed fractions. In an improper fraction, what it means is the top is greater than the bottom. The fraction's kind of a little bit top-heavy. So you can change an improper fraction into a mixed fraction or a mixed number, and vice versa. The way you do that is you look at the denominator, and so this is about halves. You actually have 3 halves. Those 3 halves is 1/2 plus 1/2 plus 1/2. Well, we know that 2 halves will make a whole. And so this ends up being 1 whole and 1/2. That's how you change that in. One way I do that is I divide how many times does the denominator go into the top. Well, it goes in 1 time with 1 left over, and we're talking about halves, so you leave that alone. Let's apply that over here. 3 goes into 4 1 time with 1 of the thirds left over. 5 goes into 12 2 times with 2 of the 5th left over. Now let's go the other way. The other way, let's turn these mixed fractions or mixed numbers into improper fractions. To do that, what you're going to do is you look at the bottom, and you're going to say, this is 1 whole plus 1/2. So 1 whole is really a half plus a half, and then you've got the other half left over here. That's 3 halves altogether. The way I kind of work this quickly is I go 3 times 2 is 2 plus 1. That's supposed to be a plus. Let me fix that for you. So 2 times 1 is 1, plus 1 is 3 over 2. 4 times the big 2 is 8, plus the 3 you've already got is 11 over 4. And 9 times 1 is 9, plus 7 is 16 over 9. Okay? There are certain fractions I think we should just really know what these fractions are. And I'm going to call them signpost fractions, or just fractions that are the most common that we should just eventually just memorize what they are with respect to decimals and things like that. And I circled the ones I think the grade 5 should know, and I threw in a couple extra ones that I think the grade 6 should know. So one activity we did in fractions, a tasty activity, had to do with breaking up licorice into different parts. So now let's talk about this as a fraction. Now for fractions, you go from 0 to 1, 0 to the whole. Okay? So this part right here in the middle is going to be 1/2 is there. This is going to be 1/4. This is going to be 3/4. Now in terms of decimals, this is 0.0. Half is 0.5. And 3/4 is 0.75. 1/4 is 0.25. So these are some of the decimal and fractions I think you should just know. In terms of percentage, to make a percent, if you get 1/4 of the questions right, the decimal is 0.25, and on a test, that would be 25%. You're simply moving the decimal over and multiplying by 100. So the midline would be 50%, this would be 75%, and 1/2 is 100%. Okay? Here's an example of a chart you might have to fill out where you take a fraction and then you end up turning it into a decimal, and for the grade 6s you end up turning it into percentage as well. The trick is, if you can turn the fraction into a tenth or a hundredth, then it transfers pretty quickly into a decimal. So let's say this fraction of 1/half. My goal is to either change the denominator to a tenth or to a hundredth. Well, this one I can make it into a tenth. So how do I turn the denominator into a tenth? How do I go from a 2 on the bottom to a 10 on the bottom? And to do that, I multiply by 5. So 2 times 5 will give me equal to 10. But with fractions, whatever you do on the bottom, you have to do on the top. So then I have to multiply that also, the top, by 5. So 1 times 5 is 5. So 1/2 is the same as 5/10. Now 5/10, then for my decimal, I know that this is the tenths number here. So this becomes, this becomes 0.5. Now in terms of percentage, I can add another 0 because this ends up being 50%. I multiply it by 100. Let's do another one. 1/4. 1/4. 1/4. It's a little bit harder to turn it into a tenth. It's not as straightforward. So let's turn it into a hundredth this time. What do I do to multiply to get this into 100? I have to multiply the 4 by 25. So I also do the top by 25, and that gives me 25/100. Now for the decimal, I know that the first space is a tenth, the second one is the hundredth. So 25/100 is the same as 0.25. There's a decimal. And now to do the percentage, it ends up being 25% multiplied by 100. Let's do another one. 1/5 is 1/5. That's an easy one to change into the 10 because I just multiply it by 2, multiply the top by 2, and I end up with 2/10. So 2/10 decimal, 0.2. And again, I could squeak another 0 in there to make it easy to figure out that this is 20%. And 1/10, well, it's already 1/10. The decimal is 0.1 or 1.10, and then it becomes 10%. These 1/3 and 1/8 are a little harder to do this way, but basically the decimal for 1/3 is 0.33, and it goes on forever. And for 1/8, it turns out that it's 0.125. So, and then in terms of percentage, this is 33.333%, and this gives me 12.5%. It's just handy to know those ones. I think it's just handy to know those ones. Okay, equivalent fractions are two fractions that represent the same thing. They represent the same amount. For example, if you eat 1/2 of the pizza or 5/10 of the pizza. It's really the same thing. There's a couple easy strategies to make equivalent fractions. Just double the top and the bottom. So 1/2 becomes 2/4, or triple it, or 3/6. So again, I can apply that here. 10 over 12, or 15 over 18. So that's just a strategy is to multiply by 2, or multiply by 3, or multiply by 4, etc., etc. Okay, here's a grade 6 part, and that is that sometimes there are equivalent fractions going the other way. Instead of multiplying, we might have to do what really ends up being some division. And we sometimes call this reducing fractions or simplifying fractions. So if in the test it says, what fraction is it, and simplify it, you're going to have to do a few more steps. To do that, this is the way I kind of work that out. Let's work at, say, 14. Sorry, me undo that. Let's do this question of 14 and 21. So I have 14 and 21. Basically, what you look for is what common factors are there in the top and the bottom? Well, I know 14 is really 2 times 7, and 21 is 3 times 7. So 7 is a common factor on both of them. So really, I can just kind of get rid of it. It's basically I'm going to divide both the top and the bottom by 7. And then the result is 2 over 3. Let's do one more. Let's do 36 by 42. So 36 I know is 6 times 6, so that might help me. 42 is 6 times 7, yep. So I got 2 6s I can get rid of, and that is 6 and 7. Sometimes what you can do is just cut these in half too. That equals 3 over 6. Am I finished? No, because there's another common factor inside here, 1 times 3 and 2 times 3, so that equals really 1 over 2. Sometimes you have to do a couple steps to figure out the equivalent fractions. So this is equivalent fractions, really reducing and simplifying fractions, something the grade 6 need to know tomorrow. Okay, we're also going to talk about ratios. And ratios, this is a grade 6 concept, they are a lot like fractions, and there's 2 different ways you can write them. One of them looks a lot like a fraction. Let's use our portable 4 data of 13 girls, 16 boys, and 29 students altogether. There's part-to-part ratios where you take a part of the whole and you compare it. So if I was comparing boys to girls, this would be a part-to-part ratio. But there's also part-to-whole ratios, and that is when you take one part, but you compare it, oops, not 39, feels like 39 some days. It's actually 29. So this is a part-to-whole ratio where you take one part of it, but you compare it to the whole. It's important that when you're doing the ratios, that if it says boys to girls, you put the boy number first and then the girl number second. Otherwise, it might not be marked. There's actually 2 different ways actually to write the ratio. So you could do it like a fraction, like this. This would be the ratio of girls to boys, not boys to girls. And you can also do the colon way, whole to, let's say, to boys. So in the colon, with a colon in the middle, you end up doing writing it as cross. Last slide, we're almost done. Equivalent ratios is a lot like equivalent fractions. Now, there's the strategies of making the numbers bigger. That's what the arrow means. Like, I would just double this, times 2, and I would get 26 over 32. So I'm taking the ratio, and I'm just finding a new ratio. If my class doubled in size, but the proportions of boys to girls stayed the same, then I would have 26 boys, and I would have 32 girls. 26 girls and 32 boys. Sorry. So that is an equivalent ratio. And again, you can also find equivalent ratios by making the numbers go down. And this is a lot like simplifying a fraction. So again, 16 really is the same as 4 times 4. And so 4 times 4 and 20 is really the same as 4 times 5. So now we got certain things on both sides. I got a 4 over here and a 4 over here. And again, by crossing it out like that, you're really going to divide. You're dividing both the 16 and the 20 by 4. And I'm left with a ratio of 4 to 5. So 4 to 5 is an equivalent ratio to 16 to 20. Finally, rates. Rates are when you kind of figure out usually how much something costs or how quick someone was or things like that. So here's a question. If 3 batteries are $1.95, what's the rate? The rate, usually I put the money or the time on top first. So it's $1.95 for 3 batteries. That's the rate. The unit rate becomes how much for 1. I know how much for 3, but how much for 1? This is the type of question where you have different rates and you want to find out what the unit rate of something is to figure out which is the best value, something like that. This becomes the unit rate for 1 quantity is 3 divided into $1.95 or 195 cents, either way. And I think it ends up, if I'm not mistaken, being 65 cents in this question. So that's how you do the rate and unit rate. That's it, boys and girls. That should be, that's the whole review from start to finish. Good luck.